Hello and welcome to the technical webinar about microgrids by IEEE Power and Energy Society. It will be introduced by Mohamed Sief, the IEEE PES Membership Development Committee Chair and IEEE PES volunteer and member since 2015. Now, in the modern power system, we have many challenges. So microgrids become a great and powerful solution. So now we will talk about many benefits from the microgrids and the topologies and application. So let's get started. Why do we need microgrids? Due to the environmental and economical benefits, the RES, which is the renewable energy sources, has increased the share of power generation from distributed energy resources, DER. Please write down the abbreviations so it will be great to remember it next slides. So the development of clean energy become important. So accordingly, the annual CO2 emissions could be reduced by 5% by 2030, as recommended by the US Power System Generation. To manage our future power demands and to be versatile and informative within the low voltage distribution networks, and also the applications of each single distributed generator will cause as many problems. Therefore, microgrids are emerging and becoming more attractive and main constituents with integration of RES based DG, which is distributed generators, units, and ESS, which is the energy storage systems of the future power grids. The topology of microgrid. The microgrid can be divided into the AC microgrid or DC microgrid. This can be briefly discussed later. In the microgrid operation, inverter is an important element which might be interfaced between the DG unit, loads, and utility grid. Also, parallel operation of inverters in microgrids is to enhance the performance of the system. It provides high reliability during any failure that occurs in an inverter. At the time, remaining units can be deliver power to the load. So, we will talk about the DC microgrids, then the AC microgrid. We will start with the DC microgrid. Nowadays, the DC microgrids are used for power distribution networks in marine, automotive, and manufacturing industries. The structure of DC microgrid can be illustrated in this figure, as you see. The solar panel, wind turbine, ESS is the energy storage systems, as we said before, and grid is connected to the DC bus, common DC bus, through the inverter. So, solar panels are connected to the DC bus through a DC-DC converter. The wind turbines are connected to the DC bus through an AC-DC converter. The ESS through battery technology is connected to the DC bus via DC-DC converter. The DC microgrid has many benefits, like the power loss reduction, voltage drop reduction, and the increase in electric lines capacity. So, the low voltage DC link in DC microgrids is simply supported by bipolar operation, wherever the loads can be connected between the two polarities of the system. Hence, the DC bipolar configuration is an enhanced selection in electrical power system. In the distribution system, the DC microgrid can be classified into three types: monopolar, bipolar, homopolar. The configurations is illustrated in the figures A, B, C. The low voltage DC link in DC microgrid is simply supported by bipolar operation, as we said before. We go to the next type of the microgrid, which is the AC microgrid. Generally, the renewable energy sources units and load can form a small isolated AC electrical power system called an AC microgrid, as we see in the figure. A typically AC microgrid system interconnected with medium voltage at the point of common coupling. Its abbreviation is BCC. All of that are shown in this figure. So the solar panel, wind turbines, and the ESS units are connected to the AC bus through DC-AC converter or AC-AC converter. Generally, the RES units and load can form a small isolated AC electric power system called an AC microgrid. AC microgrid can be classified into coupled AC and decoupled AC microgrids network configurations. The first one, which is the coupled AC microgrid, is directly connected to the utility grid through transformer, which is placed at the point of common coupling, PCC. Then, the next configuration, which is the decoupled AC microgrid, is connected to the AC-DC converter. Then, it's connected to the DC-AC inverter operation, which is directly linked to the power grid. Microgrid directly connected to the utility grid is one of the advantages of AC coupled network. This can reduce the level of the voltage than the AC and DC low voltage. In the distribution system, AC microgrids can be divided into single-phase AC and three-phase AC with or without neutral lines. The stability of the microgrid is investigated under both the generation and load dynamics of the system. The stability analysis of AC microgrid is generally damaged by the frequency drop coefficient, and it's developed by the dynamic manner of drop control. Small signal stability, transient stability, and voltage stability are the various stability problems that occur in the microgrid. In this case, small signal stability problem creates the continuous load switching, RES power limit, and feedback controller. Transient stability problem is related to energy storage, protective devices, and load shading of the system. Also, voltage stability problem in microgrid is related to load dynamics, tap changers, and reactive power limits. The stability of AC microgrid is manipulated by the grid-connected and islanded operation mode of microgrids. So now we finished the overview and concept of microgrids. So we are going to go to the next phase, which is an application. Simris project, which is a project in Sweden, um, having a mix of renewable energies and energy storage systems.